today's episode, we will build the wrap object manually and explain the classic pattern in detail. This means that the initial construction of the object is aimed at new developers in the area of the ABAP RESTful application programming model. We will build the individual layers piece by piece. So let's start with the data model of the actual database table. We can create a new repository object using the context menu. Here we can search for database table. We assign a name and a description to the object and assign it to a transport. In the next step, we define all the fields that we've already defined in the data model. You can basically start by creating the table and write down all fields and data types, even if they don't yet exist. Once we have finished creating the fields, we begin creating the various types. If we save the table, it will be automatically formatted for us. To create the first data element, we use the quick fix in the ABAP development tools. We can create a new data element via the context. The name and package are already suggested from the context, and we also define a description. If we want to create our own domain, we copy the same name into the type field. We also assign appropriate labels, which we will later see in our application. By clicking on the link, we can create the domain and navigate to it. There we enter the appropriate data type and length and activate the element. After activation, we can go and activate the data element as well. If we then click the check button, there will be one less error, and we can continue with the next data element. In this case, we create the content type. This also receives an additional domain. The reason for this is that we want to define various fixed values that we will make available later. Here we have the values CU for customer, EM for employee, and AD for address. Here too, activate the corresponding elements and then close them to return to the table. Now let's define the other important elements. We also define the data types that we use across all fields, such as the text 100 character field, which has a length of 100 characters and is case sensitive. This allows us to use it later for other fields and avoids having to create a separate domain. Another special feature of the data model is that we use the data element land1 for the country, which comes from the standard and is released for ABAP Cloud. Once we have finished creating the table, we can activate it to create it in the database. We then open the table in the Project Explorer and can create a new core data service for it via the context menu. This core data service is a base view and propagates our table externally. The CDS view has the type view entity, which is now considered standard in core data service development. The system already suggests appropriate names, which we accept, format once, and finally activate the view. We do have to make one change, however. Since we want to have a wrap object with draft functionality later, we still need to add typical draft fields to the table. To do this, we can get the code snippets from the code snippet area on the website. From the Git repository, we can copy the snippets using a simple copy button and paste it into the table. We now need to do this at the core data service level. For this, there is a second code snippet with the appropriate annotations and the prepared names. Finally, activate both objects. Once we have made this change, we can add the core data service to our wrap object. To do this, we go to the existing base view and create our new root view using the context menu. The TP at the end stands for transactional provider, because we will be implementing transactional behavior. We select the define root view entity template and generate the view. Finally, we need to remove some information and then format the view again. This completes the root view in the system. Next, we can create our consumption view on this view. So we go to the context menu, create the consumption view, assign it a name and enter the description. Finally, we select the template for the projection view. Here we also need to add the provider contract. You can find this via the quick fix. And here we select transactional query. Finally, don't forget to add the word root, as this part belongs to the root view. We also add the tag metadata allow extensions so that we later can create the metadata extension for this core data service. In the next step, we can create the behavior. We go to the context menu of the root view and create a new behavior definition. Here we will use the managed approach. Once the behavior definition has been created, we can begin customizing it. To do this, we define the alias, for example, and give the behavior class a suitable name. In the next step, we define the mapping for the table. The mapping goes from the core data service to the actual table. Here we need to map the various fields to each other. Once we are done, we generate the class in the system, format it once and activate it. This creates the basis of the behavior definition and we can look at the next part. Now we want to activate the draft in the behavior definition. To do this, we add the suffix with draft to the header. At the entity level, we add the draft table and give the table a new name. We generate the table using the quick fix functionality. This requires almost no effort other than creating and activating the table. Once the draft table is active, we can close it and return to the behavior definition. If we now click check button, further error messages will appear that we need to resolve. Here, for example, we have to add the logmaster and the eTag. Here we use the last changed field. We also need to implement the eTag master and store the local last changed date field there. Since we are in a draft scenario, we need to add additional actions that are necessary for the draft. For example, there's a draft action for edit, which we then copy and chain to the corresponding names. We will therefore add an activate action and a discard action for activating and undoing, just like for resume. For activate, we also add the optimized suffix so that the warning message disappears. If we now want to activate the whole thing, an error message appears stating that the corresponding prepare action must be added. This is a determine action. Once we are done, we can activate the behavior definition. Now we can begin creating the projection for it on the consumption view. After creating the projection, we add the alias. Otherwise, we don't need to make any further changes. Once the behavior definition is activated, we can begin creating the actual service. So we create a new service definition and give it a name and a description. Since we created the new service via the context menu, our entity is already exposed in the service. For this purpose, we assign an alias through which the entity can be accessed in the service. We also search for the annotation for the leading entity, copy the name and then paste it. The annotation causes the entity to be highlighted in the service binding at the end. Finally, we define a new service binding. We can do this again via the context menu of the service definition. There we assign the appropriate name and select the corresponding binding type. Since we want to create a UI service and working with draft, we select OData version 4 for UI. Finally, we activate the service binding and publish the service using the Publish button. This process can take a few minutes. Once activated, we can use the Preview button to start the application and preview it. Unfortunately, we currently have an error loading the application. To check the error, we can access the browser developer console using F12. If we look at the console there, we find an error message telling us that the app could not be loaded because the contact type field is defined multiple times. This indicates that our field from the Coordata service cannot have the same name as the entity type that was automatically generated. Therefore, we go to the Coordata service and change the field to content type int. We repeat this process through the entire hierarchy up to the consumption view. We also need to adjust the mapping in the behavior definition. There is also a problem in the behavior definition, so we have to generate the draft table again. Using the quick fix, we can easily generate the draft table again and then activate it. To check for further errors, we open the service binding and click the check button to obtain further information about whether there is an error or not. If there are no more errors, we can refresh the application again, and this time we will receive an empty list. Using the various settings and buttons, we can view the list of fields, display filters, and display the fields in the list. Since we don't have any data yet, we don't currently see any records in the list. Now we create a new class to generate test data in our table. We create a class in the test package within the software component. We give the class a name, a description, and add the interface for executable classes. After the class has been generated in the systems, we can begin creating an internal table that we can fill with data. We can then transfer data to the table using the value statement. Finally, we always want to delete all the data from the table before inserting the new data from our internal table. From a clean ABAP perspective, we should of course name our table after its content. Then we open the table. To have all fields available, we copy them once and paste them between the parentheses. We can then edit the entire block using the block function of the ABAP development tools. This deletes type definition and adds the empty literals. We then deactivate the block functions, delete the client field and remove the key addition. Now we can begin entering the first content into the various fields. We will first add some content so that we have something available in the display later. Once we are done with that, we will create a second dataset to validate the filter later. However, we will only change a few pieces of data, so that should be enough for the start. Once we are done with that, we will run the class once and generate the data into the table. To check the data, we will open the table and run the data preview with F8. We see the two datasets in the table and have thus generated all the test data. In this episode, we looked at how to manually create the various layers of the RAP stack and implement the draft functionality. We looked at an error case that can occur during modeling. And finally, we generated test data for our RAP object. In the next episode, we will look at the UI modeling. In the last video, we created the RAP object step by step. However, we currently lack a consistent UI for our application. Therefore, in this video, we will look at the design and structure section by section. In the first step, let's start by creating the metadata extension. This is a separate object where we can outsource our various UI annotations to keep the actual view clean and thus maintain an overview. We basically create the UI annotations at the consumption view level. Here we use the same name as the actual Coordata service. This makes it easier to assign objects later. The layer annotation isn't particularly useful so far, so we will add customer as layer here. Using Content Assistant or Control Space, we get a selection of possible fields, or as in our case, we can insert all elements directly. To be able to go through the various points of the UI step by step, we will first hide all elements. We can use the UI hidden annotation for this. To adjust all elements, we'll go through the view again with Find and Replace to hide the warning messages. We can format the elements in the view using the Pretty Printer. Finally, we update the UI and look at the initial state. Let's start by building the list report, the entry page of the most frequently used template. Similar to the selection screen of a report, we first define a view fields that the user can use to filter by default. With the UI selection field element, we define the fields for which we want to display the filters. With position, we define the order of the fields from left to right. In this case, we display the contact ID, the contact type and the country as filters. If we then reload the UI, the three fields will be displayed in the upper part and we can now filter the data. Now we want to see the first entries in the list. We can display the elements in the list using the UI line item annotation. Here we again specify the position to determine the order of the elements on the screen. The list is always the first part of the data the user sees after executing the filter. This should contain essential information that the user can use to make initial decisions. We will also display the contact ID, contact type, first name, last name, city and the country. If we then reload the application and execute the selection with Go, the data will now be displayed in the list. We will add some text above the table. We can add a description of the data using UI header info type name. There are two variants here depending on how much data is loaded. The text in the application can then be translated later. If we now reload the application, the text will now be displayed in the table header. If we reload the data once, the total number of all records in the database for the selection will be displayed. This way, we know how many records we are working with. By clicking on a record, we switch to the object page, which is the detail page where we normally find all the application's details. Since not all information can always be displayed in the list report, we can include all details and sub-entities in this list. Currently, the page is still completely empty, except for the edit and delete actions. To do this, let's first create the header with a heading and a text below it. For this, we again find a title and a description under UI header info. Using value, we can directly take a field from the entity, the content of which will then be displayed in the UI. If we go back to the Fiori UI and refresh, both pieces of information will be displayed. Now we want to display the first group of data in the header. The header is normally not editable. Here you will only find information which should provide an important overview. In the first step, we define a facet which is part of the UI. We can create various facets here, starting with the first object. A facet always requires a unique ID, which you can name freely. We usually use the ID suffix at the beginning. A facet also has a position which determines the order in which it is displayed, just like the fields and the list. We use field group reference as the type which assigns the elements from the field group area. Using purpose, we can define that the facet is displayed in the header. We use the label to give the group a heading. and we can use the target qualifier to assign elements from the field list to the group. Since we are using a field group, we will also define the elements for our field. In addition to the position, we also use the qualifier, which we use to assign the field to the facet if we have multiple facets. If we now reload the UI, the group with the title will be displayed, and the two users or fields with the content will be displayed below it. Now we define the actual content that we want to display and maintain on the page. So we create a new facet, this time of type identification reference. We don't need to define the purpose here, as the default value is standard and is therefore displayed in the main area. We define a label and a target qualifier again so that we can assign fields right away. To assign fields to the reference, we need to use the UI identification annotation. As with the field group, we define the element at the field, set a position and a qualifier to assign the element for this section. In this case, we do this with two fields. If we then go back to the UI, the new section will be loaded and the two fields will be displayed. Now let's create a new section for the remaining contact fields. In this case, we define a collection. This is a combination of several facets under a common point. The collection thus receives an ID, a position and the type collection. We also assign a label, which will later be displayed as a navigation tab. We now assign two more facets to the collection, one for the person's data and one for the address. To connect the facet to the collection, we must define the parent ID element and specify the collection ID as a reference. In this case, we define two field groups to map the remaining fields. We now assign the fields to the different field groups accordingly. We assign the first name, last name and birth to the person, street, house number, city, postal code and country according to the address. In the UI, we now see the details and within the details the two groups. Since we want to see the person in front of the address behind, we still need to adjust the positions of the two groups. After changing the position and after updating the UI, the person is now at the front, followed by the address. Finally, we create one last facet for the digital contact. For example, phone and email. It doesn't matter whether you use field groups or identifiers for the UI. With both, you can map the groups and assign different elements. The only difference here is that the annotations you use for development, which may also allow you to separate content. Let's load the UI. But we don't see any group. What could be the problem here? Let's look at the qualifier. The same problem could exist here as with the contact type. The actual ID is already assigned. In such cases, you can always try adjusting the IDs and qualifiers and see if the desired effects occurs. The last group should now also be displayed in the UI. We can now access the app's edit mode using the edit button. Here all fields are suggested for change. We can discard the current draft using discard if we don't want to change the data. If we go back to the list report, we can load the data. If we set a filter, only the one entry will be loaded. Let's create a new entry using create. We can basically fill in the various fields and the data record is created by clicking save. However, we are currently missing the key. This field is not ready for input and remains empty. Since the data record is not yet correct, we will delete it from our table. We have now built our first web application that can manage the data accordingly and whose UI allows us to display and edit the data. We have defined a large number of objects in the system, and each individual layer is required for different functions. From the database, through the core data services to the final service. We also have the behavior definition to control the object's behavior. Finally, we built our UI piece by piece in the metadata extension. In the next episode, we will make a few more changes to prepare the application for the end user. In this episode, we will create search helps for our UI, replace some technical values with text, and implement a general search in the application. In the first example, we create a search for our data element contact type, where all values are contained in the domain's fixed values. Let's take a look at the domain and compare the different values. Next, we need a new core data service to display the data for us in the appropriate format. The VH at the end of the view indicates the value help, a common abbreviation when creating the object. We will leave the reference object empty as we want to use a template right away. Before generating, make sure you are using the view entity template. In this example, we won't access the code snippet page, but will use a new IDE action that's currently still in beta. Using generate code snippet, we select the value help from data element action and specify a name for the field and the corresponding data element. After executing the action, we will receive a suggested code, which we will accept. Finally, we clean up the view and activate the object in the system. Now we run the data preview on the view and hold the view's result next to the domain. The fixed values and the corresponding texts are displayed. Now we want to implement the search help in our core data service at the consumption level. In the front of the contact type int field, we execute our IDE action again and select define value help at field in this step. Here we can enter the core data service for the value help, as well as the field name. After confirmation, the template is adopted. If you know the annotation right away, you don't need the code snippet. Now we reload the UI. If we now call the field's value help, the three types are displayed. If we select a type, it will be adopted, and we can filter the data accordingly. Now let's adjust the value help again. We actually want a drop-down menu in the UI for the three values. To do this, we need to add the annotation at the header level. Among the code snippets, we find the activate drop-down action, which inserts an annotation into the view. This defines the result set as very small, which causes the field to be converted into a drop-down menu in the UI. If we now update the UI, we get a defined drop-down menu. Here we can select the entries directly. Let's now define additional value helps in the system. In the first step, we define a new value help for the contact ID. To do this, we use the base view of the data model as a basis. Using the context menu, we can create a new core data service, give it a name and a description. Finally, remember to define the correct template for the view. Once the new view has been created, we delete some annotations we no longer need. Then we define the fields we need in the view. In the first step, we create a new compound field. For this, we combine the first name and the last name. We then define the value help for the type, as well as the consumption view, and remove fields that we don't need in the search help. If we then run the view, we get a preview of the data. Finally, we transfer the search to the consumption view. We now use a standard view in the system to have a search help for the countries. With I country VH, we should get a suitable search help. If we now run our application, the value helps are loaded for the fields. If we call the help for the contacts, we see our defined fields in the list. For each field there is a restriction option or a filter in the upper section. If we open the countries, we also receive the defined search help. In the next step, we also need to expose the search help in the service as an entity. To do this, we add the various views to the service definition. If you are unable to open a search help or it is unavailable, it may be that the view has not been released. As a final step, we correct the field in the search help. We made an error here through copy and paste, which is displayed as a warning in the IDE. Then save and activate again. Before we can show the text on the UI, we first need to define the associations to obtain the necessary additional data. Therefore, we add the new views to the root level. We define an association and use the new cardinality. This replaces the old cardinality with the numbers and should also be used as a successor. We define a one-to-one access and give the entity an alias with an underscore. This is part of the best practices. Then we define the connection using the contact type. As a final step, we need to publish the association in the view by inserting it in the lower part. We now repeat this process for the contact and the country. Now we need a value help for the user as well as a way to easily connect the texts. To do this, we define a new view in the share package. We want to share the object later, but for now we only need it for the contacts. We use the user ID, the full name, and the user's email address. Finally, we clean up the view again, run the pretty printer and activate the object. Finally, we include the view for the creator and the last changer. We will use 2 different aliases as this could involve different information. Once we are done, we declare the 2 associations in the field list. As a final step, we add the association at the consumption level and activate this object. This completes the preparatory work. We can now define the texts in the view. For this, we can use the association alias and access the field from the view. We will therefore create fields for the contact type description, assign an alias, and then define the text fields in the view for the country name, created user, and changed user field. Then we link the text to the respective keys. For this we need the annotation from the object model area and define the newly integrated text field there. Using the text arrangement UI annotation, we can define how and where the text is displayed. For the type and country, the text comes first, followed by the value in parentheses. For the users, we only want to see the text. The corresponding IDs are irrelevant. If we now go back to the UI and refresh the application, we will find the corresponding texts. For example, the type is now filled with the appropriate text and the ID. The filter at this level continues to work and now also contains the text. Previously, only the technical values was displayed as the filter value. If we now switch to the application's object page, we only see the name in the user details and no longer the user ID. In the data area, we will now find the corresponding country with the key in parentheses. This means we have now added the text to some of the technical values. In the last step of this episode, we want to enable a general search in the app for some fields. To do this, we first need to enable the search in the consumption view. Therefore, we add the annotation search searchable to the header and set it to true, which activates the search field in the UI. In the next step, we need to define the standard search elements. This means which fields of the view will be used for the search. We define the search based on the ID, first name, last name, street, and city. The fuzziness determines how precisely the text is searched. With 1.0, the value is expected exactly the same and without errors. With 0.8, we don't have to enter all the letters to get a result. In principle, we can enter a value from 0.6 to 1.0. Finally, let's test the search in the application. For example, if we enter a first name and forgot the last few letters, the search will still find the rows. If we enter an ID incorrectly, we won't get any hits. However, if it is complete, then the filter is exact. Finally, if we enter the city and forgot a letter in between, we will get hits here as well. Of course, the search also works combined with the standard elements of the other filters. This brings us to the end of this episode. We've integrated the various search helps into our application, added additional data via associations, and supplemented some of the technical values with text. Finally, the general search has been integrated into the application. Next time we will add more information via virtual fields and further finalize the UI. Last time we adapted the UI of our application and replaced the technical identifiers with text. We also implemented value helps for the most important fields to make working with the app more convenient. In this episode, we will look at virtual fields in the consumption view and how we can use them to display additional information and hide unnecessary information. We will create a constant interface and then focus on working with the fields. In the first step, we will create a new interface in the share package. Here we want to assign some constants to the contact type so that we can work with the constants later and don't have to resort to hard-coded values. We will create the constants as a structure in the interface and give them descriptive names. This allows us to access the information later in the code using the descriptive names. If we want to display additional information in our UI that may not be stored in a database, but may be derived from this information, we can use virtual elements. For this, we define a new virtual element at the consumption view level and give it a name and a type. We create 4 elements, an icon that will later look different for each type, and 3 fields which we want to use to hide certain information in the UI. Telephone, email, and birthday are fields that we don't need for every type of contact. In order for our ABAP exit to be called for the fields, we must define it for the fields. We use the calculate by annotation to specify the ABAP class we want to call. To get rid of the error, we need to create the class in the system. We can create a new class using the context menu, give it a descriptive name and a description. Then we search for the interface for the exit and find it with if saddle exit. Once we've filled everything in, we assign a transport and create the class in the system. Let's format the class accordingly and activate it. After rechecking the coordinator service, all errors should now be gone. And we can activate the view to continue implementing the logic. The class has 2 methods. We will use calculate to populate the virtual fields later, and we use getCalculationInfo to specify which fields and informations we need for the calculation. Let's first look at the method signature. This provides us with information about the requested fields and the entity that is currently being loaded. This allows us to query additional fields that we will need later. So, in the first step, we perform a check to ensure that the correct entity is being requested by the system. If it is a different entity, the logic should be exited. We then pass the contact type to the requested fields as we need this for the check and derivation. Then we can implement the second method. First, we need a type table, since we are receiving a table of type AnyTable. But we want to access the specific fields later. To do this, we map the incoming data to our new type table. Once we are finished with our logic, we pass the data back to the return structure via mapping. Now we can implement the actual mapping logic. For this, we loop over the table and work with the reference, since we want to change the data shortly. We will start with the icon for the contact type using the new switch statement and also needing the constants from the interface we have created. Using the SAP icons, we now select 3 suitable icons that we want to see later in the UI. Next, we hide the fields we no longer want to see in the UI, again depending on the type. To display an icon, for example, we need the annotation UI header info type image URL in the header. We include our new field there. Using the hash symbol and the field in parentheses, we pass the field's contents to the annotation. If we then go back to our app and update the UI, we should now find an image in the upper area of the object page. We will now use a different image for the customer than for an employee. This makes it easier for the end user to classify the entry later when creating and editing. In the next step, we want to deactivate the fields birthday, phone, and email. To do this, we use the hidden attribute in the respective annotation and set the respective field as a reference to hide the content. If we then reload the UI and look at the details, we won't notice any changes. So what's the problem with using it? The annotation is defined as a boolean and therefore requires the boolean type to function. This has been an issue in the ABAP development since the beginning, as there is no real boolean type. So we have to go back to the consumption view and replace the data type with ABAP boolean. This data type is actually recommended in all cases, since unlike ABAP bool, it is a data element and can therefore be used in more places. Once the core data service is activated, we exchange the values in our exit and reload the UI. If we now look at the customer and go to the detail page, the birthday is now hidden on the UI. The annotation takes effect and hides the elements. In the next step, we create an address where more elements are hidden. For this, we create a new data record, define the contact type attribute as address, and save the entry. After saving, the data is reloaded, and we see that the 3 fields are now hidden. However, we now have the problem that our facet is now displayed empty. Therefore, we go to our consumption view and define a new virtual element, so that we can also hide the facet in the UI. We also fill in the field in our ABAP exit if we have the address type assigned to the dataset. Finally, we go to the metadata extension and add the hidden attribute to the digital contact facet. If we go back to the UI and reload the data, the facet and the detail page should now also be hidden, giving us a clear view on this page. To conclude the session, let's take a look at the requested elements in the exit. For this, we deactivate the requested element in the getCalculationInfo method and test our behavior in the UI. To do this, we deactivate some fields in the list report so that we see our icon as a column, but not the contact type. If we now execute the selection, the field remains empty. In Fiori, only those fields are requested from the backend that the user also sees in the UI. This saves database performance, transfer capacities, and keeps loading speed low. Ultimately, however, this means that our virtual field doesn't receive the information we need for derivation, and thus the display remains empty. We request this element via the method and receive it in the method as loaded information. Basically, we also have the option of reading information from the database here to obtain the missing information. However, with the standard logic, we can achieve as few calls as necessary. Let's call the UI again and look at the list of fields. Currently, we see the virtual fields in the selection list. These normally only provide little added value for the user, as they only have a controlling character. To prevent the fields from being available for selection, we can hide them from the user. For this, we add the fields to the metadata extensions and hide them using UI hidden. If we go back to the app and refresh the UI, the fields will now disappear from the selection list of possible fields. We also use the fields to control the properties of the UI. In this episode, we looked at how we make virtual fields available at runtime and derive the correct content. We can use them to display additional fields in the UI or restrict the visibility of other fields. Finally, we clarified what we need the fields for and what influence visibility has on them. The UI is now complete, and we can look at the creation of instances in the next episode. In the last episode, we prepared the UI accordingly and implemented some restrictions with virtual fields. However, one problem still remains in the UI. When we create a new record, the type is initially unknown, and this causes fields to be displayed that should actually be hidden. Therefore, in this video, we will discuss the various factory actions. So let's start. We create 3 new factory actions in the behavior definition. We define the action as static since we want to create a new entity at any time, and it is not dependent on any other entry. We give the action an appropriate name and define the result set. An action always creates exactly 1 new entry. Then we define the permissions for the action. Global therefore means that when the application starts, the permissions for the action is defined, which determines whether the current user can execute it. We then copy the action and give each a descriptive name. Using the quick fix, we then generate the implementation, format the class, and activate both objects. Now we need to publish the actions in the consumption view so that our application has access to them. We can do this using useAction. To see the action in the UI, we need to display it via the metadata extension. It doesn't really matter which field we do this for. Here we define the actions for the contact ID on the line item, since we want them in the list. In addition to forAction, we define the actual action to be called and give it a label, then we can translate it later. Finally, we activate the objects. If we now go to the UI and refresh the application, the actions will be displayed next to the standard create. This completes the creation and implementation up to the UI. Next, we can implement the actions using an auxiliary class. This auxiliary class is connected to the wrap object and allows us to outsource functions from the logical implementation to keep it clear. Then we create the global class with the name. Unfortunately, there is no support for this from the ABAP development tools. In the global class, we define the connection to our wrap object using the forBehaviorOff addition. To make the error messages disappear, we activate both objects. We can now begin implementing the class. For this, we start in the create method of the address. Create an instance of the class and process the passed keys. We pass the SID and the draft indicator to the method using a new method in the class. We also pass the contact type so that we can create a new contact. In the method, we create a new entry for our wrap object using an EML statement. Since we are using a helper class here, we can also use the in-local mode addition. We use a value statement directly for the attachment. Since we want to return the map structure, we create a type in the class, which we can then define as a returning parameter. Now we pass the information to the EML statement. We need the SID from the action, as this is a pre-filled by the framework. We also adopt the draft flag to create a data record in the draft state. Since we want to set the contact type, we adopt it from the parameters. Don't forget that the control flag must also be set. Once we are done, we activate the class. Now we can define the method in the local implementation and fill in the individual parameters. For the contact type, we use the constant interface and finally insert the new data record into the mapped structure. Once we are finished with this method, we can copy and call and adapt it from other methods. This completes this implementation. Finally, we go to the UI and refresh the application. If we now create a new address, we land on the object page. The address type is already pre-populated, as is the icon. Since the unnecessary fields are also hidden, we can start filling them directly. In the next step, we want to implement late numbering. The data record should only receive its number when the user clicks save and the data is determined. To do this, we add the late numbering suffix to the definition. However, we now also need to recreate a draft table, as the draft UUID is required in the table. Once we have done that, we can activate the artifacts. We can implement the method in the saver class using the quick fix. In this case, we want to use our helper class again and create an instance for it. In this case, we need to loop over the mapped records and fill the contact ID. For this, we call our new getNewNumber method and pass the PID, which we will need shortly to read the data. In this case, we create the method using forward navigation and do not start in the helper class. Next, we read the contact type from the buffer using the EML statement. Since we only process one data record at a time, we read the first data record to process it later. Then we map the type to the respective constant of the interface. We first return the type as a dummy so that we can test the logic in the next step. If we create a new address in the application and save it, an ID is generated and set. To generate correct numbers, we use a number range object to generate such numbers in the system. The numbers should begin with the first letter of the contact type and then a 9-digit number. Therefore, we create a new domain for generating the numbers, which however only has 9 characters. Next, we need a number range object, which we find via the search. Since the number range object only allows 10 characters for naming, we have to restrict ourselves somewhat to create a descriptive name. In the number range, we use the domain we just created to define the length of the numbers. After activating, we switch to the Launchpad and enter Manage Number Range Intervals in the application to define the various intervals of our number range. In total, we need 3 intervals, which we want to use later for generation. We will then use the intervals 0,1, 0,5 and 0,9 for the different types. Next, we implement the number assignment in the method. We gain access to the number assignment via the CL number range runtime class. For this, we adopt the return values via inline declaration and define a separate variable for the interval. In this case, we can hard-code the object, as it will not change. Now we set the interval depending on the contact type. Employees are created in the 1 number range, customers in the 5 number range, and addresses in the 9 number range. Since we want to include the first part of the type in the number, we use the substring functions and read the first character. We then concatenate this with the new number to obtain our ID. Since the number is generated as a num_c and has a greater length than our data type, we first need to perform an internal mapping. Finally, we run a test and create a new address. For this, we enter the first name and last name and save the new address. A new contact ID is now automatically generated, which comes from the range 9 and begins with an A. This means we have also implemented automatic number assignment, but only when the data record actually needs to be saved. Now let's perform one more refactoring. We have some points in our logic that we are not using, exceptions that we aren't yet catching, and no messages that we are passing on the UI. Therefore, we will create a new return type. This time, in addition to the number, we want to create a log object that contains possible messages. Therefore, we will define a structure with 2 pieces of information. Then we pass possible exceptions from processing to the log. The addMessageException method is used for this. Essentially, we need to create the log at the beginning to prevent any errors during filling. Then we capture the 2 exceptions by using the standard class and pass the messages to the log. Finally, we pass our new number to the new structure as a result. If the return code is set by the method, then there was also an error, such as the number range being full. In this case, we want to create a T100 message. Now we create a new message class for the software component and give it a name. Then we define a message with placeholders, which we then fill during processing. To do this, we use the addMessage method to create and save a simple T100 message. Finally, we need to adjust the adjustNumbers method. Here we save the result in a new variable, pass the new number to the field, and append all messages to the others table as a wrap message. Let's adjust the UI one last time. We want to see the full name as the title on the object page. So we transfer the field to the consumption view and activate the changes. We then display the field in the title. The next step is to define the semantic key for the contact ID in the consumption view. This means that the ID is now highlighted in bold in the list report. If we now look at the object page, we will find the full name in the header. If we create a new record and exit without saving, the draft will remain. Thanks to the semantic key, we can now see the draft instance in the list, as well as some information when we hover over it with the mouse. One open point remains, however. If we look at the list report, we currently also find the standard create action for creating new contacts. We don't want to use this, as the app uses the 3 actions for specific forms. There are currently 2 solutions available. We can use create and set it internal so that the action can no longer be triggered externally. For example, neither via the UI nor via EML outside of the behavior implementation. For this, we need to adjust the definition and remove the permissions. In the consumption view, we need to deactivate the usage as the action is no longer available externally. If we then reload the UI, only our factory actions will be displayed. The second alternative is to simply deactivate the button in the UI by deleting the action in the consumption view. This means that the action is no longer available in the app, but we can still use it via EML. Therefore, we opt for the second version and hide the button in the UI. We can now create data records using factory actions and thus set the contact type directly up on creation. This immediately hides the corresponding fields, allowing us to fill in the fields relevant to us. Finally, we finalized the UI and completed the internal error handling so that any errors are passed through to the UI and our application remains stable. In the next episode, we will validate the input before we move on to the creating of the application. Currently, we can create new data records in our application without validating fields. For example, the name of an employee should be defined as a required field, as we need it in our process. We also want to have a contact for this employee in case of emergency. If we create a data record here, for example, it will simply be saved, and the important information will be missing. To do this, we first create the corresponding methods in our behavior definition. A validation starts with the keyword validation, followed by the name of the validation. A validation should always be performed when saving, to prevent incorrect data records from being saved. Finally, validation should be applied when a data record is created and updated. We will then copy the validation accordingly, as we want to create 3 different implementations. We will also create a determination that begins with the keyword determination. This will later determine address data that we need in the process. The determination should always be performed when the data record is changed, both when it is created and when it's changed. After the definition, we can create the methods using quick fix or control 1. The 4 methods are created in the behavior implementation, where we can then continue working. Let's now implement the first validation as a prototype for the other cases. To do this, we want to define a helper method in our auxiliary class to read the data from the current request. In our validation, we first create an instance of the helper class and then call the method. Since this doesn't exist yet, we can create this using a quick fix. In the next step, we still need the correct type for passing the keys into the method. We get the element information via F2 and can then copy the type to our class. We can then implement the read entity in the method. It's generally best not to read all fields, but only those required for validation. Since we want to return the result, we need to create a return type in the class. We get this information via the element information in the result of the EML statement. Once the method is fully implemented, we can format it again with the ABAP cleaner. Then activate it and close the object, since we won't be making any further changes here. Let's now begin implementing the validation logic. To do this, we go through the data records currently being checked. Here it is sufficient to process the data records that currently contain errors. This means that in the where condition, we restrict the search to records where email and phone are still empty, since at least one piece of information should be filled in. This means that all the data records within the loop are faulty. First, we fill the failed structure to inform RAP that the data record is faulty. All relevant keys are populated using the T-key field, which means we have to write less for longer keys. Next, we want to provide the user with an error message. To do this, we need to populate the reported structure. In the message field, we create the error message that should be displayed in the UI. We set the severity to error, which results in a red message in the UI. To create a message and keep it translatable, we create a new message in our components message class. Once we have created and saved the text, we can populate the message variable in the validation. Let's now test the current state of the validation and go to the UI. We create a new customer record and save it with the empty information. We now receive a corresponding error message in the UI above and via the message output. At the moment, however, the user doesn't yet know which fields is actually affected. Therefore, we want to highlight the two fields in the UI. For this, we populate the corresponding elements in the reported structure using the element. Here we set the value for both fields to on. If we now check the behavior again in the UI, the error message from above has disappeared. If we click directly on the error message, we are taken to the phone field in the UI. Both fields are highlighted in red in this case, so the user knows which information is still missing. To ensure the validation is now complete, we must restrict the contact type. Otherwise, the validation would apply to all records, but it is only intended for the customer. Now let's finalize the further validations in the object. For this, we copy our validation as a template and fill in the remaining informations. Since the key structure is not defined exactly the same, but contains the same fields, we add a corresponding as a mapping. We then adjust the checked fields so that this validation only applies to the employee. Since a different error message should appear here, we create an additional message and replace the current message in the method. The third check should validate that the first and the last name is defined for a customer and our employee. Therefore, we adjust the where condition again and restrict the data. We also create a separate error message for this case and change these fields. For the test, we switch to the UI and create a new employee. We leave all information blank and attempt to save the data record. We receive error messages for each section of the form and can use them to fill in the required fields, which are now highlighted in red on the form. Now we assign a name and an email address and save the entire dataset. For the determination, we now create a new interface. For this, however, we first need a corresponding package in the hierarchy. To do this, we first define a general package for interfaces. Below this, we then create an interface that will determine address data. To define a new interface, we use an IDE action in Eclipse. You can also find this as an open source project linked in the description. The action takes over the generation of the artifacts and establishes the various relationships between the classes. To do this, we first need a name and a description, which will be used to create the objects later. The instance name is important during processing. If all the data is correct so far, we generate the objects. Once the generation is complete, we receive an overview of the objects. From here, we can jump directly to the appropriate objects. You may need to confirm the dialog at this point to jump to the object. Let's go through the objects and format them or look at their use. We can later pass test doubles via the injector without adjusting the actual logic. The factory creates decoupled objects so that we are separated from the actual implementation. This gives us the option to create the real instance or a test double at runtime. In the interface, we define our API method, which we will call later. We then implement the method in the actual class. In this example, we first create a dummy implementation and map two postal codes to city and country. In a later video, we would then use a real API for this. In this example, we use Berlin and Cologne to provide data. After activation, we are finished with the interface. In the actual implementation, we create an instance of the service that we will then use. Here we can again copy the logic for determining the selected data records. In the next step, we call the API for each data record. Since the data records have different types, we need to map them to the target structure. Finally, we want to update the data records. For this, we use the modify entity and pass the city and the country for updating. To ensure that we will only make changes when the conditions are met, we set a where condition in the loop. The postal code should be filled in and at least one of the two target fields should be empty. Finally, let's test the determination in the UI. To do this, we create a new address and fill in the postal code. When we save the data record, the city and country are now determined and transferred to the fields. There is one thing that bothers us right now. The data is only updated when we save. This means that the user can't see whether the correct data was determined before saving. Therefore, we will change the determination logic so that it runs whenever the zip code field changes. We also implement a side effect on the field. This automatically updates the UI when the field is changed and the cursor leaves the field. To ensure the side effect is used, we must declare its use at the consumption level. If we then go into the application and create a new address, we can fill the zip code with a new value. If we then change the field with the cursor, the city and country are automatically filled. In today's episode, we have implemented additional checks in the UI to validate the completeness of the input. Depending on the input, we can use a determination to add further information without the user having to interact. The side effects allow the changes to be displayed immediately in the UI. Manual refreshing is no longer necessary. In the next episode, we will build and deploy the application. In this episode, we will take a closer look at the Business Application Studio and the functions we will need for further work. We will create our Fiori Elements application and make some adjustments using guided development. Once we are finished, we will deploy it to the ABAP environment. Before we can begin working in the Business Application Studio, we first need to create a dev space or reuse an existing one. For this project, we will start with a new dev space, since you most likely don't have one yet. We create a new one using Create Dev Space. In the next screen, you can choose between the various basic versions and additional extensions that we want to use. To begin with, the standard Fiori version is sufficient for development. We need to give the dev space a name. In this case, we will use the company name. The dev space is then created and started immediately, which should take just a few minutes. Once the space had the running status, we can start our development environment by clicking on the name. After confirming the terms, we will first clear all windows before starting work. Now we want to generate our Fiori Elements app. To do this, we will go directly to our project directory via the menu. Under File, you will find Open Folder and select the appropriate path there. Under Home and User, you will find Projects. We will go there, as this is where every Fiori application is normally created. The website will now reload, and you will find the Explorer where the folder was selected. Next, we can start the generator. For this, you will find the New Project from Template option in the menu under File, which starts the wizard in the Business Application Studio. There we select the sub-Fiori generator to start the project. The next step is to select an appropriate template. The currently available floor plans are available here. In most cases, the list report page will be used, as it is most likely like the ALV output. Now it's time to fill the essential information. For this, we select our OData service as the source. To do this, we connect to the system and select the ABAP environment from the destinations. Next, all available OData services are determined, which we can then select from the list. You can also start typing the name, which will then filter the list. After selecting, select the main entity with which our application should start. If there are additional compositions here, we could also select another entity for navigation. Under Table Type, you will find various types to get you started. The responsive table is the default. This means that only the fields that fit on the screen are displayed. The grid table is similar to an ALV. All fields are displayed side by side, creating a scroll bar. It's not necessarily mobile friendly, but it loads all information and displays it in the list. If you have a hierarchy as an entry point, you can use it to create a tree view directly. The analytical view starts directly with the view to create or display an analysis. Now we come to the project attributes. Here we define the name of the project. This is created as a parent folder and is available in Explorer. You will find the application title later in the Launchpad in the navigation at the top when the app is open. You usually need a unique combination as a namespace. In most cases, the company's domain is used here, for example. The namespace and the module name together must be unique later. Optionally, we can also specify a description for the app. In the lower section, we can specify whether, for example, we want to define the project as TypeScript. We also want to create the deployment configuration and the Launchpad configuration. In the deployment configuration, we define which objects will later be deployed where. If you don't just want to test, you definitely need this configuration. In this case, we want to deploy directly to the ABAP system as a BSP application. The ABAP repository is 15 characters long and is the BSP artifact that we will find later in the system. The deployment description is optional. Next, we specify the target package and the transport to which the deployment will be performed. It's important to specify the transport, not the task. To ensure that the tile is displayed in the Launchpad, we need this configuration. The title and subtitle will later be displayed directly on the tile when we integrate it into the Launchpad. The semantic object and the action together must also be unique and will later serve as the navigation to the actual application. You can enter anything as the semantic object. For the action, you usually use the actual action, such as manage or display. For example, what the app actually does with the data. Via the Finish button, we start the application generation. The artifacts and structures are created and the necessary modules are installed. Once generation is complete, we receive the application information, from which we can directly perform further actions. After the generation is finished, first let's start the application as a preview. For this, you will find the preview application option in the common tasks area below. After clicking, you have to decide how you want to start the application. With the first option, the application is started without mock data, and we use the data from the ABAP environment. The application is started in a new tab in the browser. If this isn't the case, check whether the pop-ups are blocked in your browser. Here you must allow the action for the Business Application Studio. Now let's run the application using Go, then our data will be loaded. This is also the first point we want to change. The user should see the data immediately when they open the application. To do this, we will find the Open Guided Development point in the common tasks. A new point will open where we search for autoload. In the list report page area, we find the option for autoload. By clicking on this point, we go to the guide and start it. In the lower part, we select the option for autoload and change it from auto to enable, to always enable autoload. To implement the change in the project, we must click the Insert Snippet button. Then the settings will be adopted into the configuration. We can see this because the corresponding configuration file has been opened. We can now close the wizard and return to the application. If we now refresh the application again, the data should be loaded directly, and manually selecting the Go button is no longer necessary. Let's take a look at the structure of the Fiori application. For this, we switch to the Explorer on the left and open our current project folder under Projects. Here we'll find the basic structure of the project. In the lower part, you will find the UI5 deploy YAML file. This file contains our deployment configuration, which we previously defined in the wizard. If you want to adjust any settings later, such as the package or transport, because it has already been released, you can do so here. In the web app folder, you will find the necessary files for your application. The manifest.json is the most important file of the project. Here you will find information about the service used, the application, the page structure and navigation, and also the Launchpad configuration. Furthermore, we will find additional folders containing the annotations, where local project annotations are stored. The file is usually quite small and the annotations are pulled from the service. This has the advantage that we don't have to redeploy the project if there are any changes to the names or fields that we have added. If you right-click on the web app folder, you will find many other project functions. Here, for example, you can directly start the application preview or call up the application info. Other points include guided development and the data editor. Using the page map, we can see the structure of the current application and could, for example, create differential navigation if we have more compositions in the project. Here you can also make further settings, for example, switching to the flexible column layout. Now let's go back to the application info to deploy the application. There you will also find the deploy task, which we will now execute in the next step. Since we have already stored all information, the deployment for the ABAP environment starts immediately. We must confirm the deployment again with Y after receiving a brief summary. Depending on the size, deployment may take some time. If you see the deployment successful message at the end, then we are done for now. We can now switch to Eclipse and refresh the Fiori folder. 4 objects have now been made available in the system. The BSP application is the actual Fiori application with all the files we saw in the Business Application Studio. The Launchpad app descriptor item is the Launchpad configuration we configured in the project. We also find the 2 SIGF nodes that have now been activated. We can now access the app and need 2 endpoints for this. Today we took a look at the Business Application Studio and the creation process for a Fiori Elements application. We made some adjustments to the app and finally installed the application on the system. Next time we will integrate the application into the Launchpad, configure pages and spaces. In the last video, we deployed the application to the system and made it available. However, we still can't exit it in the Launchpad and therefore can't assign it to a user. Therefore, in this episode, we will look at how to make the assignment, define pages and spaces, and make the application available to our user. After deployment, we now have the BSP application and the Launchpad app descriptor item available, which we now need for further installation. In the first step, we define an IAM app. This is an additional artifact that we need for authorization. We assign the app a name, a description, and a type. Since this is an external Fiori application, we select the external app type. After creating it, we assign the Launchpad configuration. This contains the application configuration and the navigation configuration for the Launchpad. If you don't know this entry by heart, you can call Content Assist using Control 1. In addition to the Launchpad configuration, the object also authorizes the service required for execution, and additional authorization objects can be assigned. Finally, we save the object. Activation is not necessary here. To make the application and configuration available in the Launchpad, we must run publish locally. This can take some time. Once we have completed this step, we can't yet authorize the IAM app. Instead, we need a business catalog. This bundles various apps into a package, and later we can combine various business catalogs into a role for the user. In this example, we can create a new business catalog directly from the IAM app, assign the app to it. To do this, click on the corresponding link in the object to start creating the catalog. Here we need a name and a description. We usually use a BC at the beginning of the name to distinguish between business catalogs. Once we've created the object, we still need to define the assignment. Basically, all relevant information is pre-filled and we only need to define the package. Once the two objects have been created, we can make the assignment directly, as we won't need it any further. In the business catalog, we now also click Publish Locally so that the catalog is available in the Launchpad. This may take a while. Once the catalog is published, we check the Apps tab. Our app has now been assigned to the catalog via the assignment. If a user receives a catalog, they can use the specific apps and other objects. We cannot assign a business catalog directly to a user. Instead, we always need a business role. For this, we go to the Maintain Business Roles tile in the System Launchpad and check whether there are already roles with ZRH. We create a new role with a description using the New button. The business role ID can be changed at any time later if you need to adjust it. In the first step, we create a role for the admin. This role can run all applications with all permissions, which is enough for us to start with. In the Business Catalog section, we now assign our catalog to the role. We start the search using add and can also restrict the search of the catalog name. We can assign the catalog with apply and then continue working in the pop-up window. With OK, the catalog is added and the editing is completed. We can then switch directly to business users and enter our own user so that it receives permission for the new role. Finally, we need to switch to general row details and set write read to unrestricted, so that the role also receives the necessary change permissions. This is especially necessary later when we work with permissions and boundaries. Finally, we can create and assign the role with Dave. To test the new permissions, we first need to log out of the system and log back in again, so that the new permissions take effect. To integrate the app into our homepage, we switch to the App Finder via the menu. There we can search for the new application and add the application where we need it using the plus symbol. Finally, we call up the application and immediately see the data. To prevent users from always having to search for the application using the App Finder, we want to set up a corresponding space directly for them. For this, we switch to the Manage Launchpad Spaces application. There we can create a new space in the system using the Create button. The ID is not necessarily relevant for the display. The title is especially important later. To keep things simple, we will leave the title and description the same and add a little more to the description. For the transport, we need a customizing transport. If you don't have one yet, you will need to switch applications again to create one in the system. Since we don't have a page yet, we will check the box here to define a page along with the space. The application will be assigned to the pages later and displayed in the group accordingly. The page title will be relevant later when we have assigned more than one page to a space. We create the two objects using create. To assign our application right away, we will add the new space to our business role. For this, switch applications again and go to the roles edit mode using edit. We can now switch to the Launchpad Spaces tab and add our new space. To do this, we will switch from Use Space template to Use Space in the pop-up, since we defined our space manually in the Launchpad. We can then search for our space in the list and select it. Don't forget to save the changes so that they can take effect. To edit the page, we open the Manage Launchpad Pages application and go to our new page, ZRH Core. We can edit the page using Edit. Let's give our new space a name, which will then appear as a heading on the page. Since we have already assigned the space to a role, we'll receive suggestions for applications from the corresponding roles, which we can now assign. This ensures that we only include applications that are included in the assigned roles. Using Add, we can define the size of the tile added to the space. Using Save, we will save the new tile. We save the current state of the page and are done with it for now. To see the new space, we need to log out and log back in so that the changes, structures and permissions take effect. If the space is not yet visible, we can edit via the menu. To do this, go to all spaces and search for our space and pin it again. Our application should now be visible in the space. We can now start this as well and are thus finished integrating it into the Launchpad. In this episode, we looked at how to package the application into an IAM app and assign it to the business catalog. We then assigned it to a role and defined a space and a page for it. Finally, every user with this role receives the appropriate permissions and should receive the space as standard access. In the last episode, we configured the Launchpad and integrated our deployed application into a space so that our users can see all the necessary applications immediately upon system login. After deployment, we adopted the basic configuration of the tile and didn't pay any further attention to the details. Therefore, in this episode, we will take a closer look at the configuration options. So we will create a new Launchpad app descriptor item. Since we can't change the deployed version locally, we can simply right-click in the Project Explorer to create a new item. We will give the item a new name and a description so we can find the artifact later. We will leave the sub UI5 Fiori application as the app type, since we want to create a configuration for it. The component ID is the unique ID we create during generation. This is a combination of the namespace and the module name. Content Assist helps you to find the appropriate component in the system. Here we are looking for the contact app. As with creating the app in the Business Application Studio, we also need to define the semantic object and the action. These are important for navigating the system and thus clearly determine the application to be called. In the upper part of the app descriptor, you will find information about the application and the type. Our component is also linked to the configuration here. Below, you will find the navigation information, such as the semantic object, the action, and additional navigation parameters that we can use for navigation in various scenarios. We will look at this part in more detail in a later article. In the lower section, we find the tiles that we will also see later in the Launchpad. We can freely customize the tile ID, and this will initially set the default tile. In principle, we can define multiple tiles directly for an application if we need them. We will set the tile to dynamic because we want to see the number of contacts on the tile later. This will activate another section in the configuration in the lower section. The tile and subtitle have already been pulled from the app and pre-populated. Since we have already stored the information, we will find it here again. Next, we want to define an icon on the tile. You can find the search help for this using the browse button. However, we can't see the available icons or what they look like here. Therefore, you will find a link to the icon explorer in the video description. Since we now want to dynamically display a number on the tile, we still need to fill in the dynamic tile details. To do this, we need the service URL from which we want to get the information. In this case, you get the information from the service binding, for example. Then we specify the entity from the service that we want to count and append count. This means the service only returns the number of records for the entity. Then we define the unit that should appear under the number so that the user knows what it represents. We set the refresh interval to 30 seconds. The current setting of 0 means that the number is read only once when the tile is loaded and then only when the Launchpad is refreshed. This means the number is read and updated at regular intervals. Now we want to replace the configuration of the current IAM app. To do this, we open the app again and replace the app descriptor item. The system asks us whether we also want to clean up the service and the authorization. We confirm this with yes. After applying the new configuration, we click the Publish Locally button to publish the configuration in the system. This completes the ABAP Development Tools section and we can switch to the Launchpad. Since we haven't updated the Launchpad yet, we still find the old tile configuration here. If we perform an update, we receive an error because the area has been hidden. With the new tile, we have a new object in the system and must first make the adjustments here. For this, we switch to the Manage Launchpad Pages application to adjust the page. On the tile, we also see the information that is no longer in the scope of the role and is therefore no longer displayed. Let's remove the tile from the space. The new app is already suggested via the side menu. This time we will adopt it as a white tile, as this is an important application for us and we want it to have a bit more space in the Launchpad. After the adaptation, the icon and number will be displayed as a preview. Now let's save the setting. Since we have adjusted the permissions and assignment here, we need to log out of the Launchpad and log back in for the changes to take effect. After logging in, the Recycling Hero space will be visible again. If we switch to the space, we will see our new tile and the number of entries will be loaded. The unit will also be displayed below the tile. When we open the tile, the 5 entries are now displayed. Today's episode was about the app descriptor item, how we can use it to further customize our tile in the Launchpad. We created a dynamic tile, integrated it into the Launchpad and finally checked that it continues to function properly. In this episode, we look at our application's permissions. So far, we have been able to run the application and see all the data records, and all actions with the data work fine. Therefore, we will first restrict various actions and then finally the data itself. First, we need a new authorization object for our data. Using the context menu in the Project Explorer, we can search for authorization and find two entries. Since we want to differentiate the data by type in addition to the actual activity, we first need to create a new authorization field. We assign our data element to this field and give it a short name. Unfortunately, we still only have 10 characters available. After creating the element, we can use the Search Help button to check whether our values are being retrieved correctly, as we want to see them later in the Search Help. Saving the object is sufficient here. Next, we create the actual authorization object in the system and give it a name. Here too, we only have 10 characters available. We can now assign our own authorization field to the object. After creating the new object, the activity field is already included. We will need this later to control the various actions and the display of the data individually. Several activities are already suggested to us in the lower section, which we also need. With this, we have everything we need to carry out the authorization check and restrictions and can now turn to the actual implementation. Let's extend our helper class to include the functions of the authorization check. For this, we switch to the helper class that we'd already created. First, we need a base type for the activity in order to subsequently create constants. This way, we don't have to hard-code the various possibilities in the code and have descriptive values for the different names. Once we have finished that, we create a new method that checks the permissions for an activity and a contact type and returns a Boolean value. Within this method, we then implement the permission check against our authorization object. We compare the activity and type against the passed values and return the result using the xsdbool function. In addition to the actual check, we create further helper methods to keep the coding manageable and simple later on. For this, we need additional return types for new methods. The first type should return the respective permissions for creating a contact for all contact types. The second type is planned for the different activities for the type. Therefore, we need all created activities here. Now let's implement the two methods in the helper class. The methods return the respective types, and for the various actions, we also need the contact type. For the different create operations, we can hard-code all values, since we only need the result of the authorization check. The second method is quite similar, but here we consider the different activities and use the passed in type. This gives us the result from the two methods indicating which authorizations are available to us. After executing the ABAP cleaner, we can activate the class and we are done. Now we need to prepare our actions in the behavior definition for the checks. For the create action and the various factory methods, we have already activated global permission checks, so a method is available to use in the behavior implementation. Now we activate the feature control for update, delete and edit. Since, for example, no type is yet defined during create, this option is defined globally. Whether a record can be modified or deleted depends on the data of the individual record, so it is an instance-based action. Once we have saved and activated the object, we still need to implement the new method. For better clarity, we move the method to the other check methods and then take care of its implementation. Let's start with the authorizations and look at the getGlobalAuthorizations method. The requested structure is used to query which field is currently being checked. We should fill the result structure with the corresponding status. The return structure contains an entry for each of the various defined fields and actions. This structure is dynamically generated from the behavior definition setting. To do this, we again create an instance of the helper class and use our new method to retrieve the authorization for the created process. We then check each action individually, and if no authorization are present, we restrict them. A constant structure is available for this purpose in the standard class. Afterwards, we can copy the line and adapt it to the 3 scenarios. Now let's test the UI and its behavior. For this, we open the application and refresh it. If we now try to execute a create action, we receive the standard message that we do not have the permissions to execute it. The second action is no better, so the permission restriction is working for us. In the next step, we want to implement the feature control. This will deactivate the entire features in the UI when the corresponding condition is met. The keys of the entities are available to us in the method, since we are working within the scope of individual instances. Basically, we have a similar structure to the permissions for the selections. In the first step, let's copy our helper class again and use the instance to read the entries for the keys. Next, we process the various data records as usual in the loop. Since we are adjusting the control flags, we first create an entry in the result table and bind the record to a reference to adjust the contents in the following steps. For this, we call our new helper method to get the settings of the current type. If there are no permissions for the action, we disable the action via the control flag. In the first step, update and edit are the same. The edit comes from the draft because we want to block the actual action in the UI. We repeat the same process for delete, but here we only need one action. Looking at the actions in the UI, we see that both actions are unavailable within the data record. In the list report, we can also select records and the delete action is unavailable. This indicates that different permissions apply to different actions. Since we have now restricted the actions, in the final step we will address the core data services and restrict the displayed data. To do this, we define a new access control on the CDS view. Here we can first assign the same name as for the core data service. We will use PFCG as the template since we want to implement a classic authorization. Then we define the fields we need from the views for authorization checks. Here we need the contact type. Within the parentheses, we define the authorization object and the authorization fields in the order they match the fields of the core data service view. Finally, we define the fields to which we assign the fixed values, such as the activity with 03 for display. After activation, we can view the data preview via the context menu. But we won't see any data there because we don't have the assigned authorization. The restriction has thus been successfully implemented. If, however, we call the preview of the consumption level, we get all the data again, since we have no check at this level and the access control is not automatically inherited. Therefore, we also create a permission check for the consumption view. The name remains the same as the view. We don't use the PFCG template, but rather the template where we inherit the permissions from the interface layer. This means we only have to implement the attribute once and can reuse it at higher levels. You should now no longer see any data records in the data preview. Let's go back to the UI and load the data records. No information is displayed here either. If we try to create a new record, we will receive the corresponding error message from the system. The easiest way to grant ourselves the necessary permissions is via the IAM app. There we can define which permissions we automatically receive when we have this tile or application. In the IAM app, we switch to the Authorizations tab and can directly assign permissions objects. Therefore, we search for our object and add it. We grant permissions for all actions except delete and assign ourselves the employee permission. After saving, we can propagate the new permissions to the Launchpad via publish locally, which may take a while. Finally, we go to the Launchpad for testing and try to load the data again. We now see all employees, but no other data records. If we try to create a new address, we still receive an error message. If we now navigate to a record, we see that the Edit button is active, but we do not have permissions to delete the record. Finally, we try to create a new employee, which brings us to the corresponding dialog. In this episode, we looked at the topic of permissions, created a new permission object and restricted the permissions step by step. Finally, we checked whether we could work with the application again with the appropriate permissions. Last time we implemented various permission checks in our application to restrict data and actions. Finally, we assigned the object via the IAM app to obtain and work with the permissions. Currently, the values are hard-coded and we cannot adjust them in the roles. Therefore, in this episode, we will look at restriction types and how we can use them to dynamically control permissions. As a first step, we create new objects, starting with a restriction field. We can begin creating them via the context menu and find the appropriate type among the objects. We can name the field exactly the same as the authorization field and add a descriptive name. Once the object is created, we need to assign our authorization field, as we will maintain this later in the permission settings. We can obtain the field via the content assist. Finally, we can check the available values using the search help button. If we activate the checkbox, we could also maintain ranges. However, since we only have 3 values, this isn't necessary. After saving, we can then create a new restriction type. We can do this directly via the link at the bottom, as this starts the wizard and also assigns the field to the new object at the end. Let's now assign a name and a description and create the new object. The field is already assigned here, so we can now assign our authorization object. This establishes the connection to maintenance. Finally, don't forget to publish the object using publish locally. To use the new restriction type, we need to assign it to our business catalog. First, we search for the type and add it to the position. Then we activate the 3 checkboxes to use the restriction type for these methods. Finally, we save and publish the catalog. Now we adjust the permissions in the IAM app and remove the contact type, as we want to manage this via the role. We leave the various activities as they are for now. Basically, the different activities are assigned to actions like write or read and are then enabled or disabled via the various restrictions. Here you should also remember to publish the updated permissions to the Launchpad. After all objects have been enabled, saved and published, we go to the Launchpad and open the Maintain Business Role application. There we access the ZRH admin role and enter maintenance mode via Edit. We can start maintaining individual permissions using the Maintain Restriction button. Currently, the permissions are set to unrestricted, which applies to all permissions. Therefore, we set write and read to restricted, thus activating the maintenance of these objects. We can now maintain the contact type for which we want to grant permissions. For testing purposes, we set write and read for employee and only read for address. Finally, we save the role so that the new permissions are applied. Returning to the Launchpad in our area, we see 4 data entries already displayed on the tile, and we open the application. There we now see employees and addresses for which we now have permissions. If we go to the employees record, we can still edit it, but deletion is not possible because we don't have the necessary permissions via the IAM app. If we now access the address, we cannot edit it, and creating a new address also doesn't work. Now let's go back to managing the role and set the values to unrestricted. Save the role and go back to the application. There we can again see and edit all types of contacts. To obtain all permissions as the administrator, we adjust the permissions for the IAM app and also activate the checkbox for delete. Then we publish the new permissions to the Launchpad. We now can check whether we can also delete the data records again. All actions are now available again on the object page, and we therefore have all the permissions we need as an administrator. We can now restrict permissions to the data via the role to offer our users only the relevant data. Likewise, only authorized employees can edit the data, and apart from the administrator, no one can delete the data records from the system. That brings us to the end of this episode. In this episode, we finalize the contact app and populate the application with proper data. We will look at an open source project, load the data into our application using EML, and finally adjust the UI to display the correct data. To load the data, we use an open source project that can also be used to provide test data containers via GitHub. We utilize the central repository and the JSON editor on GitHub to load the large data package and populate the data in our application. In the repository and the README file, you will find further information on using the project, as well as additional examples. Link to the project in the video description. Let's take a look at the data in the repository. In the new folder data, you will find a JSON file where we have already stored employees, customers and addresses. If you want to access the actual data without the website, you can view the file path and the JSON file using the raw button. We will also need this path to load the information into ABAP. For development, we will use our old test class, where we already have created an initial dataset. Except for deleting the data in the table, we can remove the old logic. In the next step, we create a new method for loading the data and have it created using Content Assist. We want to create the new contacts using an EML statement, since we want to reuse the automatic numbering and the validation of the data records. Now let's define the path to the GitHub file as a constant in the class. To use the test data framework, we need a configuration. We pass the GitHub path and the file name to this configuration to create a new configuration. We can then pass the configuration to the factory to generate a new instance of the framework, which we return to the caller using returning. Since the structure created in the JSON already matches our target structure, we can load the data directly into the internal table. Now we only need to write the EML statement and pass the data to the RAP framework. During the create statement, we specify which fields we want to insert. This eliminates the need to populate the control structure of the table, saving us several intermediate steps. Because we also need to populate the SID for the framework, we use autofill, which uses generic IDs. Since we have no dependencies within the hierarchy, this is sufficient for our purposes. To detect any potential errors, we create the return types failed, mapped and reported and output them to the console. You shouldn't forget the commit either, so that the changes are persisted after the EML statement. If we then return the class, we should receive the new data records and their references as output. If we look at the data in the data preview, we find it with the new numbering. Currently, we have gaps in the numbering that resulted from our experiments with the data records and features. In the next step, we want to reset the number ranges and regenerate the data to have complete information. To do this, we open the Manage Number Range Intervals app in the Launchpad and go to the maintenance section for our number ranges. There we open the first interval and can adjust the current value using the Change Number Range status button. We then reset this to 0 and must confirm the warnings. Generally, you should consider this, especially in the test and productive system. Since we are in the development and will be discarding all the data afterwards, this isn't a problem for us. Now let's execute the logic again and populate our wrap object with the data. After execution, we go to the data preview and check the data. Now the numbers should start at 1 and we no longer have any gaps in the data. The data has been successfully loaded and the first set of data is available to us. Let's go back to the UI and look at the data in the system. We currently have 26 data records from the various areas. However, in the list report, it's noticeable that the text for the addresses doesn't look very good. Since first name and last name are not required fields for the address, we have a lot of empty fields here. Similarly, we have several companies among the customer, and here too we have empty spaces in the second field. If we navigate to the object page, we get an unnamed object for the address. We'd like to correct this. For this, we go to the application where the actual text is generated. Currently, the full name in the value help is only composed of the first name and the last name. Therefore, we adjust the field generation. We can easily do this using functions in CDS. If it's an address, we want to use different logic than before. We take the street name and a comma and append a city name to the end. In the data preview, the full name is now populated with all the information. Now we can use the full name in the appropriate places. For this, we go to the metadata extension and remove the line item from first name and last name to hide the fields in the list report. In their place, we now display the full name. If we check the UI, we now see no more gaps in the list report. Only the heading isn't quite right. We add the end user text label to the field, and with that, our application is complete. The application is now in the state we want. A proper title is now displayed on the object page, including for the address. In principle, minor adjustments can still be made, such as hiding the contact ID or the name for the address. In the first step, we will leave the app as it is and begin the configuration in the next episode. Until then, thanks for watching and see you next time.